Welcome back to CIS 209. In this topic, we're going to talk about attributes, also known as fields or columns. So when we are defining attributes, let's remember that each entity is comprised of rows, which are instances of the entity, and the vertical structure in the two-dimensional matrix are columns or attributes. So each attribute is something the entity has one, not many of. This is really important. If the entity has many of something, it's a relation. It's not an attribute. So you might think of each attribute as being related one-to-one to the entity which it describes or contains data about. Each attribute's value is determined by the primary key of that row. Again, functional dependency. So the student ID for student 1 perhaps is an ID, and that ID determines the student's name and their contact information as opposed to the student's name. One class I taught at the very beginning of my teaching career, I was flabbergasted to see that I had two students named Robert E. Benson. So obviously I couldn't tell just from Robert Benson, the name, first name, middle initial, last name, which one it was. I needed a student ID to be able to figure out which data was about which of the Robert E. Bensons. Interesting story. Each attribute must be atomic. So it can't be a repeating group like student 1, comma, student 2. So the datum in the intersection of row and column must be a single chunk of data. Each attribute is a column containing data that describes that instance of the entity. So it could be a toaster that comes in mauve and green. Well, that'd be two rows, and in the color for the first one it would contain mauve, in the second row it would be green. And attributes are often constrained by business rules regarding their possible values. This is typically something you'll find in your analysis and design. As you gather requirements, they may say, well, yeah, we need to make sure that the ordered quantity is a positive number, and it has an upper limit of, say, 10,000. So now we know it's a business rule where an ordered quantity must be between 1 and 10,000. We could categorize our attributes into different types. A primary key is a type of attribute. You'll only have one per table. It could be a natural key or a surrogate key. You'll have a foreign key perhaps. In every many-side table you will have a foreign key, which is always of the same data type as the primary key of the one-side relation it links the many-side relation to. And then the other columns will be data-centric columns, which will be describing characteristics of that entity instance. Each attribute will have a specific data type. And we need to be real careful about this and make sure that the data type that we choose is appropriate for the data to be stored in there. So for numeric data, we probably intend to do math with it, either needing to sum, average, or count. There's kind of a raging debate about whether or not phone numbers, for instance, should be numeric. You can still make a data type character-based and constrain it to only digits. So if you're not going to be doing math with it, you might want to select a character data type. And there's other folks that argue, hey, it's a number, it's a number. We'll format it with dashes and things, but it's actually stored more efficiently as a number anyway. So if we're going to be sorting, grouping it by, it's probably okay to make it numeric. A date data type indicates something that occurs in time. We don't want to make character data and stick a character set into a date data type. One of the interesting things about almost every database management system, it internally stores those dates as numbers. So we can perform mathematical operations of adding and subtracting dates. Calculating a due date of an invoice based on terms is something you can do as long as you have the date being stored numeric. A text data type is basically character. For descriptions, for names, any non-numeric, non-date type data, very most common type of data type is text. Your Boolean data type is simply true-false. Internally it may be represented as 0 or 1, but we shouldn't be concerned about that initially. We just need to know that it's an indicator. That's another type of name that you'll find. Many Boolean fields are indicators, yes, no. And then we have binary data can be used for media, for graphics, binary large objects, character large objects. You're going to find a video, for instance, like this file we're playing right now, would be a binary data type. Let's talk about some more business rule things. Attributes may be constrained to a range of values. You can have lookup entities that give you a set of categories for something. You could have a valid value list that is represented by a drop-down list box. Or you could have a business rule or consistency requirement for numeric and date type data. An attribute may be required or not required. If it's required, it cannot be null. So we have this term called nullable. Most spell checkers turn that red underline on when you see that word nullable, but it simply means if it's required, it cannot be null. If it's not required, then it can be null, therefore it is nullable. You may or may not need to have a default value supplied. Many times if you have a field that cannot be null, it's helpful to do some analysis, find out what the most frequently used value is in that field, and then supply that as a default value.